All right, so this is our last little short video for this week. I wanted to talk about motion problems again. Now, we already did motion problems where we went from like position to velocity or position to velocity to acceleration. So we already did motion problems where we took derivatives. So now we want to talk about motion problems where we're going backwards and you're having to integrate. All right, so question number 1 here says find the position function if you know s of 2 equals 7 and you've got this velocity equation. All right, so if I've got the velocity function and I'm trying to find position, I got to go backwards. I have to integrate. So position is going to be the antiderivative of this. So that's going to be 3t cubed over 3 minus 2t squared over 2 plus a t plus c, right? And so I can simplify that, and I'm getting t cubed minus t squared plus t plus c. And then they give me this initial condition here. So this is really just, if you think about it, this is just doing a particular solution is all you're doing. You're doing the integral for both of these. All right, that's really all you're doing. You're doing the antiderivative of both of those, and then putting the plus c, and then you're using your initial condition to solve for c. So you've technically already done this. We're just talking specifically about motion problems right now. All right, so I know s of 2 is 7, so I'll get 7 if I put a 2 in here. So 2 cubed minus 2 squared plus 2 plus c. So 7 is going to equal 8 minus 4 plus 2 plus c. So that's going to be 8 minus 4 is 4 plus 2 is 6. And then if I subtract 6, c is 1. All right. So then if c is 1, then I'm able to plug that back into my function right here to get my answer. So that means s of t is going to equal t cubed minus t squared plus t plus 1, because my c value ended up being 1. All right, so that's just integrating, going backwards. If you know velocity, you can figure out your position, but you need some type of initial condition to figure out the constant from integration. All right, number 2, same thing here. Find the position if you know the acceleration. So this time I've got to do it twice because I have to integrate the acceleration to find the velocity. So that would be negative 3t squared over 2 plus c, just doing the antiderivative. And then I'm going to use my initial condition to solve for c. So right here I know that v of 1 equals 0.5. So that tells me when I put a 1 in here, 1 squared plus c, I'm going to get the answer 0.5. So 0.5 equals 1 squared. That's a negative 1.5 plus c. So then I add 1.5 over here, and c is 2. All right, so that tells me my velocity function then is going to be negative 3/2 t squared plus 2. All right, so that's my velocity function. So now, in order to find position, because that's what I'm supposed to be doing, is find a position, I'm going to integrate again. So I don't have to technically do this every time, but that's what you're doing. You're doing the integral. So the antiderivative of velocity is position. And then on this side, the antiderivative would be negative 3/2 t cubed over 3 plus 2t plus c again. And then I use this second initial condition that they gave me to figure out what c is. So when I plug a 2 in, see these 3's will cancel. Those 3's cancel. So I get negative 1/2, and then I'm plugging in a 2, so 2 cubed plus 2 times 2 plus c is going to give me an answer of 3. So 3 equals 2 cubed is 8. So that's going to make negative 4 when you multiply that by negative 1/2. Plus 4, those cancel. So c ends up being 3. And then my final answer then for my position function, which is right here. So s of t is going to equal, that 3's canceled, so that was negative 1/2 t cubed plus 2t plus my c value, which I found my c value was 3. So here is my final answer. So negative 1/2 t cubed plus 2t plus 3. All right. So we're just doing motion problems and going backwards. No biggie biggie. All right, so this one says, given s of 1 equals 3, find s of 4. All right, so you can do this the same way. All right, if I know my velocity equation is 2t minus 3, then I can integrate both sides, and I can put my bookend behind them, and I can find out the antiderivative of velocity is position. And the antiderivative here is going to be 2t squared over 2 minus 3t plus c. Just don't forget your plus c. These 2's cancel. All right. So then they gave me this initial condition right here. So they told me s of 1 is 3. So when I plug a 1 in here, so 1 squared minus 3 times 1 plus c, I'm going to get the answer 3. So 3 equals 1 minus 3 plus c. So that's going to be negative 2. I'm going to add 2 over here. I'm going to get 5. So c is 5. So my equation that I'm going to have, I'm going to write that down here. My equation I'm going to have then, s of t equals t squared minus 3t plus my constant, which I just found to be 5. Now what the problem wanted me to do was to find s of 4. All right, so that means now that I've got my position function, I can figure out s of 4 by just plugging a 4 in. So 4 squared minus 3 times 4 plus 5. So s of 4 equals 16 minus 12 plus 5, which is going to give me an answer of 9. All right, so my answer is 9. Now you'll notice I have left this whole right side empty, and I did that for a reason. All right, so what I'm going to do is I'm going to show you a different way to do the problem. All right, there was another way we learned to do this too. We know that it says if you're given s of 1 is 3, find s of 4. There was another way to do this problem that I taught you. If you want to find your new value, that's going to equal your old value plus the change. All right. So my new value I'm trying to find is s of 4. That's what I'm trying to find. The old value that I already know is s of 1. And then what I want to do is add the change that has happened from 1 to 4. Because if I know s of 1, I'm trying to find s of 4, I need to know, well, what's happened between 1 and 4? And if I'm integrating and finding position, I have to integrate velocity. Right? So I can do this. My new position is my old position plus my change in position. And my change in position is integrating velocity because that'll give me position. And the over the interval from 1 to 4 is how much I have moved. So all I have to do is do this problem this way. So s of 1 I already know is 3 plus. Now I can just put in the velocity equation in here. V of t was 2t minus 3. So I'm really doing this. I'm integrating 2t minus 3. All right. So I won't go up so far. So s of 4 equals 3 plus, what's the antiderivative of this guy? Well, that again is t squared minus 3t. I don't need the plus c because I'm going to evaluate from 1 to 4. So s of 4 equals 3 plus, and for this I'm going to do the fundamental theorem of calculus. So I'm going to put a 4 in first, so that's 16 minus 12. And then I'm putting a 1 in, so that'll be 1 minus 3. So s of 4 equals 3 plus 4 minus negative 2. And s of 4 is going to equal 7 plus 2, which gives me the same answer, 9 again. So a different way to do the problem, thinking of integrals, I can think of, this is, I guess you could also think of this when we did it before with derivatives, you were thinking of doing the equation of a tangent line. So your new y coordinate was your old coordinate plus m times the change in x, which is your derivative. So it's just a different way of thinking about the problem, all right, using an integral. All right, so you could either find the particular expression first and then substitute in the value you're trying to find, or you can think of this idea that my new value that I'm trying to find is my old value plus the change that has happened since then. All right, so for problem number 4, let's see, let's do last thing, problem number 4. I want to talk about displacement and total distance traveled. All right, so the difference is if you want to just find your displacement, all right, which means how far you have moved. So think about the problem I just did. My new position is my old position plus my change. This is displacement. All right. How much I have displaced or changed from my old position will give me where my new position is. All right. So just doing straight up integral of velocity is displacement. All right. So if I want the displacement over the interval 1 to 5, I'm just going to do 1 to 5 and do the integral of 2t minus 3. That's displacement. That tells me how much I have moved over the time interval 1 to 5. All right. So then that's just doing the antiderivative. We know that's t squared minus 3t. And I'm going to evaluate that from 1 to 5. So I'm going to do the fundamental theorem of calculus. All right. And we're going to put the 5 in first. That's 25 minus 15. Then we're going to put the 1 in. So 1 minus 3. So that's going to be 10 plus 2, because I'm going to get negative 2, and then I'm minusing negative 2. So that answers 12. All right. So that means I'm displaced 12 units from where I started. Okay. Now, the other thing the problem wanted me to find was the total distance traveled. Well, the difference here to find total distance traveled is you just have to take the absolute value. All right. So the total distance traveled is going to be the integral of the absolute value of your velocity. All right. So that's going to be the absolute value. The absolute value of 2t minus 3. So when you take the absolute value, that means you're adding all together both positive and negative movement. All right, so it doesn't matter whether you're going forward or backward, you're making it all positive and you're summing it up, which gives you your total distance you've been traveling, both going forward and backward or left or right, depending on which way you're going. So total displacement, all you do is do the absolute value of the function of this is your velocity, the absolute value of your velocity, integrate that over your time interval. All right, so that's total distance. Displacement is without the absolute value. Total distance is with the absolute value. Now, to do this by hand, you would have to rewrite the absolute value as 2 different integrals, like a piecewise function. Make sure you split it up if where this breaks is in between here. Let's see, this is going to break at positive 3/2, so at 1.5. So yep, you'd have to break it up from 1 to 1.5, and then from 1.5 to 5, and you'd have to do the 2 different expressions, which remember this is a v, so one of them is actually 2t minus 3. The other one is the reverse, negative 2t plus 3. And you'd have to integrate that and add the 2 different ones together, do the fundamental theorem, and add both answers together. So the easiest way to do it is to math 9 it, of course. So if we just math 9 that, like we've been doing with all of our area problems, you're going to get the answer 12.5. All right, which means that we did a little doubling up because the displacement I am from my original spot was 12. So I have backed up a little bit, 0.25, and gone over my traversed my same distance over that 0.25 twice to give me 12.25. So that's what is happening. So I actually traveled 12.5 as opposed to just 12, if that makes sense. So I doubled up on a little portion, like a half a unit or something like that. I traveled over a unit, a fourth of a unit twice. Like I'm 12 from where I started, but I traveled a little bit and came backwards. So maybe I went to 12.25 and then I came back 25 to 12. I could have started at 0 and gone to 12. But I could have traveled up to 12.25 and then came back to 12, which means I traversed that 0.25 twice, which is why I actually traveled 12.5 units. All right, so that's your total distance traveled compared to your displacement from where you started when you started traveling. All right, so I hope you remember that from last year, using absolute value bars to try find total distance traveled. All righty, so you'll be able to do all your practice problems.